Hello, algebra students. Welcome to lesson 17, where we're going to be talking about combining like terms. Now we're going to dive right into the lesson practice for this right after just a little bit of instruction on what like terms are and what they are not. Like terms are terms that have the exact same set of variables, okay? The letters of the variables have to be the same, and all of the variables have to be raised to the same power. I call that a variable set. Okay, so I include both the letters and the powers of the variables in a variable set. So whenever I say that two terms are like terms, notice we're using the word terms, so we're referring to numbers that are separated by plus and minus signs in an expression. Like terms can have different coefficients, but that's the only thing that can be different is the coefficients. The variable set has to be exactly the same. Here I have 3x to the fourth. What does that mean? That means 3 times x times x times x times x. And 5x to the fourth. That means 5 times x times x times x times x. I can combine like terms. So what I'm going to do is I'm going to look at the first term, and I'm going to look at the third term here, and I'm going to look at what sign is in front of the third term. I notice there's a plus sign there. And the way I can combine these is I can take this first term and add this second x, this 5x to the fourth term to it to get a total of 8x to the fourth. Now, why is it at 8x to the eighth? Why don't I add the exponents? Remember what exponents are. Exponents are repeat multiplication. And I'm not doing any multiplication. In this case, I'm only doing addition. I have whatever x to the fourth is, whatever that number is, I'm multiplying it by 3, and then later on I'm adding the same number but multiplied by 5. So whatever x to the fourth is, what is the quantity of that value, of that x to the fourth that I'm actually going to have? I have 3 of it, and then I have 5 more of it. Does it make sense that I have a total of 8 of x to the fourth, whatever that amount is? That's why I add the coefficients, but when I'm adding like this, I don't touch the variable set. The variable set only gets affected when we multiply because it's repeat multiplication. Exponents are repeat multiplication. And I'm not going to worry about the exponent here because I'm not doing any multiplying. All I'm doing is addition. Okay, so in this lesson, all you'll be doing with these variable sets is addition. Now, can I add the 5y to the fourth plus 5y to the third? I cannot because they have different variable sets. If this is 5 times y times y times y. And this is y times y times y times y. There's 4 of them. This is y times y times y. It's a different number than y times y times y times y. So because these numbers are different, there's no realistic way for me to add them together. I can't add 5y to the fourth plus 5y to the third. I have to leave those separate. So what do I get when I actually do this addition problem? Well, what we're going to run into is some problems that can be worked and simplified. Some things in my problems won't be able to be worked. So I do 8x to the fourth, okay? Because I combined the 3 and the 5x to the fourth. My variable set behind stays the same because I'm only doing addition. Plus 5y to the fourth. I can't change 5y to the fourth because I have nothing that I can add to it. And then plus 5y to the third. And again, I can't change 5y to the third because there's nothing I'm adding to it. This is my final expression. All right, now let's jump down to the practice problems and see how we can actually work real problems that involve these numbers. All right, letter A. Negative 2xy minus 3x, different variable set there, plus 4. There's no variables on 4, so that means I can only combine it with other numbers that are just numbers without variables. Minus 4xy minus 2x. Okay, now I'm looking here for things that have the same variable set. xy, both raised to the first power, xy, both raised to the first power. I can combine these two numbers. How am I going to do that? Well, I'm going to combine them by looking at their signs. Here's negative 2xy. What sign is out in front of 4xy? It's negative, so it's going to be minus 4xy. Negative 2xy minus 4xy is going to be negative 6xy. Can I do anything with this minus 3x? Well, later on there's a minus 2x. So I have minus 3x. I look to the sign up front for the sign that I'm going to include. Minus 3x minus 2x is minus 5x. I combine these because they have the same variable set. All I'm doing is adding or subtracting the coefficients. Notice I subtracted the coefficients. Here, the first time I subtracted coefficients, and then 4 can't be added to anything because it doesn't have a variable, so its variable set is blank. I can only add other numbers to 4 that have a blank variable set. And that's how we do letter A. Let's move on to letter B. In letter B, I have negative 7m. No, I'm sorry, positive 7m. Well, that would have been a big mistake. Minus the opposite of 8m plus 9m. Now, whenever I have a minus the opposite of something, that's confusing. I don't want a confusing value, especially these negatives in here, because I know those negatives are just going to throw me off. So I'm just going to remember that subtracting is adding the opposite. So this is I'm going to turn this into an addition problem. Plus, the opposite of negative 8m is just 8m plus 9m. So I'm going to add all three of these together. 9 plus 8 is 17 plus 7 is 24. My answer is going to be 24m. All right, let's move on to letter C. Letter C is 3YAC minus 2AC plus 6ACY. Now, here's something that you need to ask yourself. Can any of these variable sets be rearranged? Because I noticed that yak here, it kind of looks like AC here. It has the same variables. Remember, multiplication is commutative. It doesn't matter what order I do it in. So I could change this to 3ACY, and it's the exact same thing as 3YAC minus 2AC plus 6ACY. If I wanted to, I could put the 6ACY next to the 3ACY. Let's do that because addition is also commutative. So this would be the same expression as what's above. So what do I have here? 9ACY minus 2AC. Can I combine the AC with the ACY? No, I cannot. Different variable set, can't add them. Let's go on to letter D. In letter D, I have x to the fourth y plus 3x to the fourth y. Let me just go back and turn this into a, there we go, 3x to the fourth y. And then my last value with its variable set, 2x to the fourth y. Now I'm noticing that all of the variable sets are exactly the same, x to the fourth y. The only thing that's different is the coefficients. I'm also noticing that this first number doesn't have a coefficient, so that means it has an implied coefficient of 1, okay? So this is just going to be the problem 1 plus 3 plus 2. 1 plus 3 is 4, plus 2 is 6. This is going to be the same thing when I simplify it as 6x to the fourth y. All right, moving on to letter E. X squared y minus 3ayx plus 2yx squared. I wonder if that's the same as the first variable set. We'll have to see. Minus 2xy plus yx. Okay, now I'm just going to say this. Multiplication is commutative. So any of my terms that are a bunch of multiplied variables, I can switch around the order of the variables and I still have the same number. I'm going to do that here. So I'm going to rewrite this problem as I write it out with everything in alphabetical order. So here's x squared y. Okay, that is actually what's there. Minus 3, I'm going to change yx to xy, alphabetical order. Plus 2, I'm going to change yx squared to x squared y. Minus 2xy, that's already alphabetical, plus xy. Anything with xy as a variable set can be added. Here I have my implied 1 right at the beginning, x squared y. Oh, that's not xy though. Minus 3xy minus 2xy. I can combine that to make negative 5xy plus xy. Negative 5 plus 1 is negative 4. So I know that in my expression here, I'm going to have minus 4xy. But what about what comes before the minus 4xy here? Well, I see that I have 1x squared y plus 2x squared y. That's going to be 3x squared y. I can't combine these any further because they have different variable sets, so I just have to move on to the next problem, letter F. Letter F is m to the third n plus m to the third n, ooh, both of those have an implied coefficient of 1, minus x squared y to the 7th plus x squared y to the 7th. Okay, so I'm going to write this out, m to the third n, and I'm going to set that up right, and then I'm just going to copy and paste it because it's exactly the same. Plus itself, okay, there we go. And then, let's see, minus x squared y to the 7th. That's an interesting variable set. I'm multiplying x times y times y times y times y times y times y times y. All right. Minus x squared y to the 7th, and then plus x squared y to the 7th. So I need to change this to a plus. Okay, now I'm going to notice something. Here I have negative x squared y to the 7th plus x squared y to the 7th. Notice I'm adding the opposite of a number to itself. What happens to a number when you add its opposite? It becomes 0. So I don't have to worry about x squared y to the 7th. This answer is just going to be 2m cubed n, or m to the third n. All right, there we go. On to the last one. The last one is letter G. A triangular shaped display case has the dimensions shown on the diagram. Find the perimeter of the display case as a simplified variable expression, then evaluate it for x equals 2 feet. Okay, so perimeter is just addition. I'm going to add these sides together. It's going to be x plus 1. Normally I put this in parentheses, but I'm just going to note that I don't need to put terms in parentheses if I'm just adding them all together. So it's going to be x plus 1 plus x squared. Okay, and then I have one side left, and that last side is plus x squared plus 1. So I'm just adding x plus 1, that's one side, x squared another side, x squared plus 1 the third side. Well, I can combine like terms here, and I have three different variable sets going on. First is 2x squared. I have 1x squared plus 1x squared. Add the coefficients to get 2x squared. Plus x, I have 1x all by its lonesome. That's going to stay that way. Plus 1 equals plus 2. All right, and now if we evaluate this expression for x equals 2, it's going to be 2 times 2 squared. Well, 2 times 2 squared is just 4. So it's going to be 2 times 4 plus 2 plus 2. That's going to be 8 plus 2 is 10 plus 2 is 12. The answer here is going to be 12 feet of perimeter. All right, and that's how you do it. So this lesson is a little complicated. It's mostly complicated to remember it later. Since I just explained it to you, I don't think this is going to be that difficult. But the next time you have to do this, you have to remember you can only combine numbers by adding the coefficients of things that have the same variable set. And then the other tricky part of this is keeping track of positives and negatives. You also have to do that. All right, you are ready to get started on lesson 17, problems 1 through 30.